All right, guys, today we have linear functions and their transformations. You really need to pay close attention to this. Take great notes. Please take good notes on this one. There's some new things for you in this. You need to really, I said again, you just got to pay close attention. Take some good notes. Here we go. Way back in Algebra 1, a long time ago, you'd spent some time doing something called a slope-intercept method. The slope-intercept form of a function or an equation look just like this. F of x equals mx plus b, and that's the m stands for slope and the b stands for the y-intercept. Therefore, it's called slope-intercept method. And so what you can do with that is, I give an example right here, f of x is 3x plus 4. This is what you used to do in Algebra 1. The 4 represents the y-intercepts. You would go up to 4 on the y-axis right there. The number in front of the x, the m, stands for slope. It doesn't make sense. Slope, m stands for slope. But slope is, remember the words rise over run. That's what slope means, rise over run. How the graph rises compared to how it runs. How steep it is. The bigger the number, the steeper it is. In this case, it's 3, so it's 3 over 1. So I'm going to start at the 4. I'm going to rise 3 units and run 1 to right there. And then I'm just going to connect those 2 points. We'll sing a song about that tomorrow. And there's your line. And that's what you did in Algebra 1. That's perfect. You can graph lines that way all day long. Slope-intercept form is awesome. Very easy to graph your lines, as long as you know which one's a slope, which one's the intercept. Hope that was just review for you. Okay, the new stuff begins now. Another way to graph lines is called the transformation method. And we're going to do transformations on a lot of shapes this year, so I need you to kind of understand as we go through this, even though you could do slope-intercept form, and you just could, we're going to go with transformation method tomorrow in class to kind of introduce that to you. Now, this right here, f of x equals x to the first power. Notice there's no exponent, there's nothing, just an x. And also, think about this, f of x, even though it's a function, is just a function notation for y. F of x is just a different notation for y. So it's really like y equals x. Okay, this is called the parent function. There's nothing with it, just plain ox. And what happens with the parent function, it goes through 0, 0, because there's no y-intercept. Look at it. The slope is 1, because 1's in front of the x. And it just does it like this. This would be terrible if I'm trying to draw this. It should go through 1, 1, 2, 2, 3, 3, negative 1, negative 2, all that stuff, right down through there. That's called the parent function. That's just y equals x, or f of x equals x. Now, if you notice on the slide, I put the words vertical shift. Anytime there's a number outside the x, like x plus 3, what that does is it takes that graph and shifts it up 3 units. So instead of it starting at 0, 0, it's going to start up at 3. Notice this point was at 1 right there. It's going to go up to 4. Every point on that line has been shifted up 3, right, because of the plus 3 at the end. So if I connected all those, it would be parallel to that one. It's supposed to be, and I'm not hitting it very well. But that whole green line got shifted up 3 units. And the same thing is going to happen with that minus 2. X minus 2, instead of going up 2, the whole thing is going to be shifted down 2. So instead of 0, it's going to go down 2. Instead of this point at negative 1, it's going down to negative 3. Instead of this point at 2, it's going down to 0. So if you just connect those points, I'm drawing terrible lines here, but you can see what's happening. The number outside shifts your parent graph, shifts that green line either up 3 or down 2. The number outside shifts it up or down. That's what it does. All right. Next thing is reflections. If you throw a negative in there, if you throw a negative in the front of the parent, it reflects it across the x-axis. I'm going to draw the parent one again. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, all those, and goes this way also. There's your parent function, just what we did on the last slide. Now what this negative sign does is it reflects everything across the x-axis. So reflect means basically flip. So I'm going to flip that graph across the x-axis. So this part of the graph right here is going to be reflected down here, right? And the part of the graph that's down here is going to be reflected up there. So the red graph got reflected across the x-axis. Now, if you go back to slope-intercept form, what really happened is the slope got changed from positive 1 to negative 1. So instead of rising 1, run 1, we rose negative 1 and ran 1. Okay, that's the slope-intercept form way. All right, I'm going to combine the two right here. Okay, First of all, I have a negative x, which means it's been reflected across the x. So I'm looking at the blue line. But it's got a +3 outside. Don't forget what the +3 does. The +3 shifts that graph up 3. So the blue line used to be at 0 right here, going up 3. It was at 1 right there, up to 4. Everything's being shifted up 3. And it's going this direction because it's been reflected. I don't know why it keeps growing like that. It's been reflected across the x-axis. All right, so if it's a positive x, it looks like the red line because that's the parent. If it's a negative x, it's been reflected, so it goes the complete opposite direction because the whole thing has been flipped over the x or reflected across the x-axis. And then the +3, like we said a few minutes ago, that shifts it up 3. If it's been a -2, it shifted down 2. Okay, I got one more slide. Hang in there. Doing great. All right, vertical stretches and shrinks. This is the last thing we're adding today. All right, so here's what I'm looking at on this first one. Well, let me do this first. Let's draw that parent graph like we've been doing. The parent one starts at 0, 0, goes through 1, 1, 2, 2, 3, 3, 4, 4, all the way through there. Goes down -1, -1, -2, -2, all the way down there. That's the parent. Right now, let's look what's happening here. First of all, it's been shifted down 1. So it's got a -1 outside. It's been shifted down 1. So I'm going to start it down 1 instead of a 0. Right now, the other thing is there's a 2 in the front. Haven't seen that yet. What that 2 does, that's called a vertical stretch. If it's a number bigger than 1, absolute value of bigger than 1 is a vertical stretch, which means this. Instead of going up 1 over 1 to right there, I'm going to go up 2 over 1 to right there. It's getting steeper. Up 2 over 1. It's the slope. It's basically the slope, but we're going to call it a vertical stretch. So if I connect those blue ones, I'm going to try real hard right here. I missed. To connect, but it should be steeper, a lot steeper than the green. Now, let's do one more of those. Look at this one. Okay, first of all, I see a +2. The +2 on the outside means it's been shifted up 2. I'm trying to find a color here. Up 2, so instead of starting at 0, I'm going to start at 2, starting up 2. There's a 3, which means that's a vertical stretch by 3. So instead of going up 1 over 1, I'm going to go up 3 over 1. But there's a negative. This has everything in it, which means it's been reflected across the x, which means this can go the opposite direction. So instead of going up 3 over 1, I'm going to go down 3 over 1. There's my other point. And really all you need is 2 points to draw a line. We'll go one more right there. And I don't know why that keeps doing that. Connect them. And that should be the steepest. The bigger the number here, the bigger the vertical stretch. Those are both vertical stretches. I guess I should have done this. If you have a number less than 1, let's say you have a 1/2 in front, something like that. A 1/2, because it's less than 1, the absolute value is less than 1, it is actually a vertical shrink. And that's basically the slope. So instead of going like up 1 over 1, you go up 1 over 2, which is going to make it much flatter. It's going to make the line look a lot flatter. So if it's got a number bigger than 1 in the front, the bigger the number, the steeper the line, the bigger the vertical stretch. The smaller the number is, the smaller the fraction is, the flatter the line because it's been shrunk. All right, and we'll talk about this a lot in class tomorrow. Look at some examples. I hope you took some good notes. I got some gestures for you. Got everything you need. I know you're like, can't wait for those, but they're really good. They're really good. So I'll see you tomorrow or Monday, whatever the case may be, in class, and we'll work it out. See you then.